Hello and welcome to this video on factoring the sum or difference of two cubes. So this is two different formulas we're going to look at, two different factoring methods, one for the sum of two cubes and one for the difference of two cubes. Alright, so there's several examples. The first of which I have here is factor each polynomial. I'm going to have several, so factor each polynomial completely. Alright, well, the first thing you do in factoring any polynomial is, look at all the terms and do all the terms have a greatest common factor other than 1? And this is not the case right now. Z cubed and positive 125 have a greatest common factor of 1. Now, some things I'm noticing I want to point out are, that this is two terms, z cubed, positive 125, right? It is a sum, right? And I'm seeing powers on the variables that are a multiple of 3. So anytime you have a variable to a power that's a multiple of 3, you have something that can be written as a cube. So this is going to be a sum of cubes. And let me show you a general formula, a general look for a polynomial that is a sum of cubes. A sum of cubes looks like this. You have some expression, I'll use capital A, to the third power, plus, and then some other expression, I'll use capital B, to the third power, right? So a sum of two cubes. And when you have a sum of cubes, it is factorable. You should be able to rewrite a cubed plus b cubed as the product of a plus b. Alright, so in this first factor I would say it's very simply just get rid of the cubes, right? It's just a plus b. And then another factor, times, and then in the next factor you have a trinomial, 3 terms, where it starts off with a squared, and again you think about what we're doing here is reversing multiplication. So later when I check, when I distribute the a, right, I want a times what, would give me a cubed back. So this first term is a squared. Then there's going to be a third, I'll do the third term next. The last term in this second factor is for when I distribute the b, I get a b cubed, so you got b squared there, plus b squared. And then in the middle term, what I like to point out is that for the sum of cubes, and you'll see later for difference of cubes, in this second factor, you start off with a squared, and then the power of a decreases in the next term, and then there's no a to be had in the last term. And the power of b increases. There's no b here, and then there's a b in the second term, and then b squared in the last term. And then one last little thing to make sure that when I multiply we get a cubed plus b cubed and no other terms. This sign here before the second term in the second factor is minus. So a cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. Okay. You'll see that this sign, again, this first factor, I have the same sign in the middle here, plus I just got rid of the cubes, right? Just get rid of the cubes and got a plus b one factor. And then this sign between the two terms in the next factor is going to be the opposite of this sign. Alright, so these are opposite signs. And then this last sign, the plus here, is always a plus, plus b squared. You'll see that for a difference of cubes as well, which I'll probably read in the next example, where we have a difference of cubes. Alright, so right now, again, I've got two terms. I'm seeing a sum plus and powers that are multiples of 3. So I'm thinking I might have here a sum of nice cubes. Let's rewrite this these terms so that I see them as cubes? Well, the first one's easy. It's z cubed, right? Z to something to the third power. Z to the third power plus. And then 125 is 5 times 5 times 5 is 5 to the third power. And you can check that. 5 times 5 is 25, and then times 5 again would be 125. So it is a sum of two cubes. And then this z that's being cubed is like the capital A. I can replace the capital A's throughout my little formula over here with z. And then the 5 is like the capital B. And I can replace all the capital B's in my formula with the number 5. So let's do that. So z cubed plus 5 cubed can be factored to z plus 5, right? Again, just simply removing the cubes, really. Z plus 5 is one factor, times, and then z squared minus, okay, the opposite sign after that first term in the next factor, and then, AB. So z times 5. Well, you can write z times 5, but I'm going to make that, 5z. That's the AB, 5z. And then always plus. All right, plus, and then I'll write 5 squared for right now. Okay. So there's your a squared minus, ab z5, and then plus b squared. And I'm going to simplify further. 5 squared, 5 times 5 is 25. So this is z plus 5 multiplied by z squared minus 5z plus 25. And there you go. And do say factor completely, so you might want to check this one. But I'll tell you right now, for these sums of cubes and also differences of cubes, if you've already pulled out the greatest common factor, in the beginning, which here there wasn't anything, it was just 1, the a squared minus ab plus b squared is going to be prime. You're not going to be able to factor this any further. So z squared minus 5z plus 25, you can't factor that over the integers any further. Okay, so this is it right here, the factored form of z cubed plus 125. And let's check that. I'll actually write it out this time for this first example. If I distribute the z, right, that'd be z cubed minus 5z squared and then plus 25z, right? That's distributing the z to the z squared minus 5z plus 25. I'm done with the z. Now I move over to the positive 5 and distribute that. Right? So we have plus 5z squared, and then 5 times negative 5z would be negative 25z, and then 5 times 25 is positive 125. And you see what's happening over here. When I multiply this out, you get the z squareds are canceling, negative 5 and positive 5. You get the z to the firsts are canceling, positive 25 and negative 25. So indeed we are ending up with z cubed plus 125, which is exactly what I had in the beginning. Wonderful. So z plus 5 times z squared minus 5z plus 25. Okay, so my next example is going to be now the sum of very minor difference. It's going to be a difference of two cubes. All right. So I've got here, where I have to again factor completely, 8 times p to the third minus 27q to the sixth. So again, I'm seeing two terms, right? 8pq to the third, negative 27q to the sixth, two terms. It's a difference, right? This time subtraction, and the powers on variables, are multiples of 3, right? 3 and 6. So that's an indicator that I might have, again, might, doesn't mean it's going to be, I might have a difference of two cubes this time, right? It's a subtraction, difference So let's look at what that looks like in general. So a difference of cubes. So this is where you have, something to the third power. Again, I'm using capital A. Something to the third power, 1 cube, minus, right, difference, and then some other expression to the third power as well. Well, you're going to see that this difference of cubes has a very similar factoring to the sum of 2 cubes. All right, in fact, I'll keep that sum of cubes that I wrote up earlier up here. So a cubed minus b cubed factors to the first factor in the product. Again, just like I did up here, just get rid of the cubes. A minus b multiplied by, and then it looks almost exactly the same as for the sum of cubes. I need a squared for the first term so that I get a cubed when I multiply. And then the sign between the first term and the second term is the opposite of this sign here. This was a minus, so I'm on plus here. Plus, and then the power of a decreases, power of b increases. So the next term is plus ab instead of minus ab. Very minor difference. And then the last term in this second factor is again positive plus b squared. So that way, again, when I'm multiplying, I get negative b times positive b squared, giving me the negative b cubed. All right, so I see very similar formulas for the factoring of the difference of cubes as for the sum of cubes. And if you want to double check, distribute the a, distribute the negative b, and combine like terms, you'll see that you end up with just a cubed minus b cubed. All right. So let's take a look at this with the two terms and powers that are multiples of 3 and a minus sign. Let's see if this is a difference of cubes. Well, 8 and 27 are nice cubes, right? The first term, 8p cubed, that's 2p to the third power, right? 2p times 2p times 2p would be 8p cubed. Minus, and then this 27q to the 6th. Well, 3 to the third, 3 cubed is 27. And then q to the second, q squared to the third would be q to the 6th. All right, if you took 3q squared times 3q squared times 3q squared, you'd get 27q to the 6th back. Great, so I'm seeing that, yes, indeed, this is a difference of 2 cubes. So this 2p is going to replace all the capital A's, and this 3q squared in the parentheses here is going to replace all the capital B's in my formula for the factoring of difference of cubes. So let's do that. So the way this factors, right, the first factor is simply get rid of the cubes. So this 2p cubed minus 3q squared cubed factors to 2p minus 3q squared times, okay, so there's your a minus b, times, and then the a squared, right? So the 2p, right, that whole thing, so I'm putting in parentheses, that there's your capital A, 2p squared, plus, right, the opposite sign in the middle here, and then AB, right, A times B, so 2p times 3q squared, replacing the A with 2p and the B with 3q squared, and then plus again, and then B squared, so this 3q squared, right, all in parentheses, right, this whole thing is the B, right, squared. I know there's lots of parentheses here, but we got the big ones here closing off all three of these, right. Now, when you square this, I've got 2p minus 3q squared times, and then 2p squared is, 2p times 2p, that's 4p squared, plus, and then 2p times 3q squared, that'd be 6pq squared, and then plus, and then 3q squared squared, or 3q squared times 3q squared would be plus 9q squared. And there you go. Alright, there was no GCF other than 1, so this should be prime, and you can check it on your own if you want. That's not factorable over the integers any further. So there we have it. The way this breaks down is 2p minus 3q squared, 2p minus 3q squared times 4p squared plus 6pq squared plus 9q squared. Okay. And double check by multiplying. You'll see that it's the same as the original. The next one we have, we've got, now here's one where it's not a difference of 2 cubes or a sum of 2 cubes to start with. Negative 16a to the 4th minus 54a. Notice my powers on the variables here aren't multiples of 3. So chances are, it's not a sum or difference of 2 cubes. But there is a greatest common factor, right? And again, that's the first thing you should look for whenever factoring anything completely. What's the greatest common factor of all the terms? So my terms here are, negative 16a to the 4th, negative 54a to the 1st. And I'm also noticing that my lead coefficient is negative, so I'm going to pull out the opposite. I'm going to pull out the negative GCF. Well, the greatest common factor of these two terms is, 2 goes into each of these evenly, right? This is 2 times 8, that's 2 times 27. And they both have a factor of at least a to the 1st, right? So 2a, but since the lead is negative, right, since my lead coefficient is negative, what I'm going to do is I'm going to factor out the opposite of the greatest common factor. I'm going to factor out negative 2a. Alright, so let's see what happens when we do that. So I've got negative 2a coming out, and when I remove a factor of negative 2a, what I'm left with is, negative 2a times 8a cubed would be negative 16a to the 4th, and then negative 2a times positive 27 would be negative 54a. Right. So there's a GCF, or the opposite of the GCF, coming out, and then the factor afterwards, right, this 8a cubed plus 27, looks to me like it's going to be a sum of 2 cubes. Right. This is a sum of cubes, and I'll actually bring this over to the side here. 8a cubed plus 27, right, is, what? 8a cubed is 2a to the 3rd, right? 2a times 2a times 2a. Plus 27 is 3 to the 3rd. Okay, so this 2a is like the capital A back in my sum of cubes formula, and the 3 is like the capital B in the sum of cubes formula, right? So it's going to replace capital B throughout. Okay, so the way this factors, one is, the one factor will be just get rid of the cubes. So 2a plus 3 multiplied by, and then the first term in this next factor would be 2a squared, right? So 2a times 2a, that'd be 4a squared. And then minus, right, opposite sign next, and then the capital AB, right? So 2a times 3, 2a times 3, 6a, and then always a plus after that, and then the last term in here would be the b squared, 3 squared, and 3 times 3 is 9. All right. And there's your factoring of 8a cubed plus 27, 2a plus 3 times 4a squared minus 6a plus 9. So going back to the beginning, I'm not done. That's not the answer. I was asked to factor, negative 16a to the fourth minus 54a. I pulled out the GCF. That's not going anywhere. So I've got negative 2a, this is the opposite of the GCF, times, and then the 8a cubed plus 27 factors even further to times 2a plus 3 times 4a squared minus 6a plus 9. And there we go. This, in the box, is the completely factored form of my original polynomial. And you can always double check by multiplying. When I multiply these two, you can distribute the 2a, distribute the 3, combine like terms. When I multiply these two, I get 8a cubed plus 27. And then I multiply by negative 2a, right? Just distribute the negative 2a. I get my original back. Wonderful. Alright, so I have one last example where we're doing this, again, pulling out the greatest common factor or the opposite of the greatest common factor, and that's this example here. So right now, it's not exactly a sum or difference of two cubes. One is because 3 and 375 aren't nice cubes. What's the cube root of 3? Not a very nice number. It's something between 1 and 2, and what's the cube root of 375? Again, not a very nice number. So I'm not going to leave it this way. Now I could think of it in these two ways if I wanted. If you like having the negative, if you don't like having a negative in front, like this, you can rearrange the terms. I could say this is positive 3 and then minus 375 b cubed. Oops, this should be a 5 there, sorry. 375 b cubed. And look at it this way. These are the same expression. All I did was rearrange the terms. Right? Alright, so what I'm going to do is look at it over here. So I'm going to first look for the GCF, and because the lead is negative, again I'm pointing that out, the way I have it written here, the lead coefficient is negative, so I'm going to factor out the opposite of the greatest common factor. Now looking at these two terms, the greatest common factor is 3. 3 goes into 375 125 times, 3 goes into 3 once, and that's it, right? So what I'm going to do, because the lead is negative here, is factor out a negative 3. Alright, so negative 3 comes out, and then when negative 3 is removed as a factor, what's left over is 125 b cubed minus 1. Right? Negative 3 times negative 1 would be positive 3. And then keep going. Alright, this factor can be factored even further. Alright, this one's you can see a minus here. This is a difference of two cubes. And how is it a difference of two cubes? Let's see. 125b cubed. That'd be 5b to the third power. Right? 5b times 5b times 5b. Minus, and then 1 is just 1 to any power, so you could say that 1 is the same as 1 cubed. Right? 1 times 1 times 1 is 1. So you're seeing that this here is actually a difference of two cubes, where 5b is like the capital A I was using in my formulas for the factoring of a difference of two cubes. And the 1 I could replace the capital B with. And so this would factor, and I'll just write it at the end here. We got negative 3 pulled out earlier. Okay, I pulled out negative 3, the opposite of the GCF. And then this 125b cubed minus 1 would factor to 5b minus 1. Alright, one factor where I just remove the cubes. Times, and then 5b squared. Right, 5b times 5b. So 25b squared. right there in the next factor. Then plus, right, the opposite sign here, and then 5b times 1, right, the capital A times capital B, or just 5b, and then always plus before that last term in that last factor. 1 squared, 1 times 1, also just 1. And there you go. Alright, here's a completely factored version of negative 375b cubed plus 3. And if you want to double check, multiply. If I multiply this by this, I get this back, and then I distribute the negative 3, I get that back. It works. Now, as I said, you could have also decided, hey, I don't like having the negative in the lead, so I rewrite it this way. Well, this time, I will pull out just 3, right? My lead coefficient is positive now. So I pull out just 3, and then what's left over when I remove 3 is 1 minus 125b cubed. And then this here is a difference of cubes. Right? 1 minus 125b cubed is just reversing this over here. It's just the other order. This is 1 cubed minus 5b cubed. So the way it would factor be a little different looking, but it still ends up being the same expression. You have I have the 3 pulled out times, and then one factor where I remove the cubes, 1 minus 5b times, and then 1 squared plus the opposite sign here, and then 1 times 5b, and then always plus, and then 5b squared, 5b times 5b, 25b squared. Sorry about the edge of the page there, is 25b squared. So you see how these are actually the same thing. Okay, what I have in the box over here, the purple box, is the same as what I have in the blue box over here, right? Look at the factors. 1 plus 5b plus 25b squared, that's exactly the same as this one here, just in a different order. All right, in the opposite order. Now I know you're saying, hey, there's negative 1 minus 5b. This has 5b minus 1. But that would be the same if I took, this one has a negative 3, this one has a positive 3. If I were to take the minus sign, right, anytime you have a negative sign, it's just like saying times negative 1. If I were to take this minus sign here and distribute it to the 5b minus 1, I'd get negative 5b and then plus 1. So these, in fact, are the same expression. All right. So we've seen a couple examples of now, a sum of 2 cubes, a difference of 2 cubes, and just the last couple of examples there were just to remind you that whenever you're asked to factor anything, pull out the greatest common factor first, or the opposite of the greatest common factor if the lead is negative. All right. And as always, I like to say, read your texts, go through, whether it be online or a hard copy, go through it, read through your text maybe multiple times, try to understand things on your own, work through examples on your own, and don't just give up after the first attempt. And but if after several attempts, if you're not understanding things, then it's not a weakness, not a sign of weakness at all to reach out to a tutor, a teacher, a friend who knows the stuff. Look for videos like this one or something better than this one. There are plenty of better videos, I promise you. Just and work at it. Be patient. Just takes time, patience, and practice to get good at most anything. And I know you can do it if you just stick to it and try to have fun with it. Thank you very much.